Good morning, good afternoon, good evening, wherever you are across the world. Welcome to our 5G Network Deployment Options webinar. Again, my name is Charlie Martin. I'll be your host for the next hour. And we're going to go through a short presentation today on 5G Network Deployment Options. Before we get started, I wanted to mention a couple of things. I am recording this session, and we plan to make this recording available to you all later on. You'll get a communication from us in the not too distant future that you'll have access to this presentation and to the recording. So I'm doing that right now. So just wanted to let you know that. Secondly, I have a partner. He's actually in the session right now. His name is Bhupinder Bajwa, and he is also a 5G subject matter expert here at Award Solutions, and he'll be helping out with Q&A during the course of our webinar. So what I suggest is that as we're going along, if you have questions, go ahead and chat them into the chat function, and then Bhupinder will be helping me to take a look at those questions and to arrange them. And what I'll plan to do is that for the last, say, 10 to 15 minutes of our webinar is to go ahead and go into those questions and answers. Okay, so that is the plan for today. So let's go ahead, and I'd like to explain some things about Award before we get started, in case you've never had Award Solutions training before. We have trained over 100,000 students on LTE since 2007. And on top of that, we've trained over 11,000 students on 5G since 2016. So wireless is very much one of the big things that we do, and networking and other things that you'll see in just a little bit. We have over 75 employees globally. We have maintained on a scale of 0 to 5, a 4.7 SME rating over the entire period of time where we've been operating, which is over 20 years. We have trained over 25,000 students on network virtualization. 98% of our students taking our courses would recommend them to others. And we have had over 255 corporate clients over time. We are the trusted training partner for the biggest mobility conferences worldwide. So we've been the partner with Mobile World Congress for quite some time. And so we were this year as well at Mobile World Congress in Barcelona. We'll also be there for the Mobile World Congress Los Angeles show that's in partnership with the CTIA. And we're also official training partners with the CCA, okay, the Competitive Carriers Association here in the United States. And we were nominated as Minority Supplier of the Year by a Tier 1 U.S. service provider, the Regional Minority Supplier Deployment Councils. I just want to go into a little bit about ourselves before we get into the 5G deployment options. In terms of our expertise, as I said, wireless is a big one. 5G is right at the center of it right now, and LTE as well, and VoLTE. New things like beamforming, CBRS, non-standalone and standalone 4G, 5G network architectures that we're going to talk about today. And also newer things like artificial intelligence, automation, LTE Advanced Pro, license assisted access. So just a whole slew of technology. In fact, we maintain that we have this depth of knowledge across all wireless and IP technologies. Okay, so just in case some of you have not taken our courses before we get started, I also wanted to talk about a couple of special offers from ourselves. We have a couple of three offers actually that I'm going to discuss, where we have a special promotion. So we have a combination of a Welcome to 5G on-demand course, along with a tech primer on 5G services and architecture. We have these sessions starting September 5th and October 8th. And if you use this code here during the sign up of this, and all you do is you go to our website, www.awardsolutions.com, and you'll see these courses that are available. You'll save 30%. All right, and this is valid through August 31st. And what's going to happen is that in order to make this easier for you, Bhupinder is going to go ahead and chat this information to you on the chat window. And so if you're interested and would like to sign up for those, you'll have that information in chat. Second special offer is a course on 5G in our air interface, starts October 14th. Again, saving 30%. There is your code to use. And this is valid through August 31st. And then the third offer is a course on 5G networks and services starting on August 26th, and of course, valid through August 26th. And Bhupinder will chat this information to all of you, and so you can go ahead and find it there. Okay. Just real quick, I ask, well, you're all automatically muted right now anyway, but if you wouldn't mind staying muted so we don't get any kind of background noise during the course of the webinar. And of course, go ahead and please chat me any questions that you have. And we'll go over a Q&A at the end. Please don't record or photograph this session. You're going to get a recording anyway. All right, I'm recording that. And please place your phones on silent mode. Thank you for that. Now we're going to go ahead and, okay, a little bit about myself. Again, my name is Charlie Martin. My background is very much wireless, 3G, 4G, 5G. I've actually worked on 1G in the past, probably giving away a little bit about my age there. And what I've specialized in is radio access networks design, optimization, and troubleshooting. That's been my background for 30 plus years, okay, at the operator and at the vendor. So now let's go ahead and start talking about 5G deployment options. So in this, over the next hour that we're together, we're going to go ahead and look at the 5G network architecture. We're going to go over that. We're going to explain the different possible network deployment options that an operator might choose to use in moving towards becoming a 5G operator. Okay, we're going to talk about the different actual numbers. There's actually a numeration of those deployments. There's a numbering of those deployment options by standards, and we'll talk about those. And we'll talk about the advantages and disadvantages of each of the strategies. Before we get started, just a refresher on, if any of you have not looked at 5G network architecture before, the thing that stands out, we have an all new 5G next generation RAN, and we have a new base station called the G Node B here. And we have an all new core network that's based on NFV, network function virtualization. So we know that in the past with LTE, our evolved packet core, we had the four main nodes, the MME, the HSS, the S gateway, and P gateway. Plus we had the policy and charging and rules function and all that. Well, we're going to now replace those dedicated hardware solutions with virtualized software solutions. And so we show here things like this, the access and mobility management function. Management function. Well, guess what? When you look at what the AMF does, it looks and feels a lot like something that we had in the past called the MME. Okay? We have something called the authentication server function. And we have something called the unified data management function. And when you look at those things together and you think about what node does those things in 4G, you realize something called the HSS, the home subscriber server. What does it do? It's a big subscriber database. That's its main first function. The second thing that it does is it's involved in authentication and security. What we've done here now in 5G is we separated out those two big functions, and now those will be virtualized network functions. We have something called the policy charging and charging function. Looks and feels an awful lot like something that we had in 4G. You probably can guess at that, called the PCRF, policy and charging rules function. We have the user plane function. Looks and feels an awful lot like some nodes called the S gateway and P gateway. Provided that user plane function for transporting user data network. User data, transporting user data. Okay. And then we have something called the session management function. Looks and feels an awful lot like what the P gateway did for session management in terms of hosting IP addresses and managing the IP sessions in the 4G network. Okay, so what the big takeaway is, we're moving towards network function virtualization in 5G. Okay, and then we also have a host of other functions. These are just some of them. Network slice selection function, a network repository function, network exposure function. There's a lot of these. There's a number more of these functions. I'm not going to go through them all. But when you look at what's happening with our next generation core or our end-to-end QoS, we've got a lot more flexibility now and capability, and it's all going to be riding on top of NFV. Okay, so I just wanted to review that with you really quickly. Third thing, big takeaway here is that we're moving from S-based interfaces to N-based interfaces. Remember in 4G, we had these terms like S1 MME and S1U and S5 and all of that. Now we're moving to these N interfaces. For example, N2 is the interface for carrying control plane information between the G node B and the AMF. And the N3 interface is going to be the interface for carrying user plane data from the G node B to the user plane function. Okay, so that's our 5G network architecture in a nutshell. Here are the different options that we'll be talking about over the next half an hour. Okay, and I just want to point out a couple of things before we start getting into them deeply. At the top, we have option 1, 2, and 5. These would be called standalone options. Standalone options. And what that means is that when we deploy the network, for example, here you see the E node B, and in terms of the RAN, we only have the 4G RAN there. It stands on its own, can communicate with the core, the EPC there, no problem. Stands on its own, stands alone. Here, so option 1, that's just an LTE network. That's all it is. Okay. Option 2 is a standalone 5G network. We have the G node B and we have the 5G core, and we have the N interfaces, and the G node B radio access network stands alone, works just great, communicates with the 5G core just fine. Okay, and then we have option 5 here, in which we have a 4G radio access network talking to a 5G core network. In this case, the E node B has been upgraded with software to allow it to understand 5G interfaces and protocols. And this is also a standalone option. Okay. In this case, this would be called a next generation E node B. Just a little bit of terminology. I'm going to introduce some terminology above and beyond what we've got in the charts here at some places during this webinar. Now, so those are standalone options at the top. At the bottom, we have non-standalone options, non-standalone or NSA options. What you'll notice here is that we have two types of radio access technology or radio access network. Okay. And so in those options, what stands out is that what happens is that the new technology that we're introducing, for example, in option 3, what you'll see here is we're using the 4G core, the 4G RAN, and we're introducing the 5G RAN, all right? But in order for the 5G RAN and also for the UEs, 5G/4G UEs that are going to be in the network, in order for them to communicate up through the EPC, we need help. The G node B needs help here. And so what it is that we have help from the 4G E node B to get connectivity back to the core. And so that's a non-standalone option. I just wanted to differentiate between the two. And then now we'll move on to talking about each of these. But at the bottom, all these are non-standalone options. Okay. Another thing I just want to point out really quick, you're going to see this little M here, a little M here, a little M here. That stands for master. All right. And what happens is in these non-standalone options, these are actually called multi-rat dual connectivity options. Multi-rat, so more than one rat, more than one radio access technology. And there's a special subset of these. It's called the ENDC, which stands for EUTRA New Radio. New Radio dual connectivity. Well, the EUTRA means LTE, so this means LTE and 5G NR dual connectivity. And now you'll see for each one of these options at the bottom, two things: 4G LTE and 5G new radio. Now let's go ahead and start looking at those options in more depth. Here's option one. Again, I mentioned this is just straightforward LTE. If you're an LTE operator today, and if you're an end-to-end operator where you've got your own radio access network and your own EPC, then you're in option one architecture today, starting point. Okay. Option two was the second standalone option that we showed at the top. And what is it? It's just 5G end-to-end network. Okay. So 5G RAN, 5G core, supporting the new interfaces, the end interfaces, and that's our option two. Okay. And so now what we'll be talking about, a lot of the emphasis on these options that I'll be talking about in the next couple of pages is, okay, today if you're an already existing LTE operator, how do you get from option one to option two? Okay. Or let's say that you're an MVNO, okay, a mobile virtual network operator, and you offer services, but it's not over your own network, it's over a partner's network. Maybe you want to now become a full, not virtual, but physical operator where you own your own network, right? So those options are going to be talking about how you can get to the target. And to me, the target is option two. All right, now we're going to talk about option threes. And so this is very much defined in standards. These numbers are standards-based numbers that I'm using. All right, and so option three, what stands out about this, first of all, we said it's non-standalone, right? And what's happening here is that we want to introduce our 5G RAN. Well, let's say that we're an operator and we're trying to get it to market as fast as possible. So fastest time to market, fastest TTM, right? Maybe what we might want to do is say, I want to leverage my already existing evolved packet core. Is there a way I can bring the benefits of the 5G RAN, right, to the market as fast as possible? Can I do that without deploying a 5G core? The answer is yes. And that you can do that. Option three is one of those paths. Okay. So at option three, which you're going to see, option three and option 3A, you've got the 4G evolved packet core. And of course, you'll have the eNode B, right, if you're deploying an end-to-end 4G network. But the key here is that I want to introduce the 5G GNode B, all right? And what I'm going to do is that I'm going to specify that the eNode B is the master node, okay? And that all signaling that comes from the 5G UE that gets to the 4G core must come through the master node. It is the signaling anchor. So what we mean by the term signaling anchor, all messaging that goes from the UE up to the EPC must go through the master node. It can go through a couple of ways. Now, we've got here in dotted lines is control plane. In solid green is user plane, okay? And so what we need to separate out is what are we doing with signaling versus what are we doing with user plane, okay? So we're going to implement an interface between 5G RAN and the 4G RAN. In standards, it's called X sub X, and in this case, X sub X is going to be equal to X2. So the normal base station to base station, E node B to E node B interface that we've been using for 7, 8 years plus, the X2 interface, we're going to reuse that. Okay, so now we have connectivity between the 5G G node B, the 4G E node B, and then we can send signaling, all right, this way to the core, or we can go this way. Everything has to go through the E node B as the master node. And as far as the user plane goes, we're going to introduce something called the master cell group bearer. There's a couple of terms here. Again, I want to explain. There's MCG and SCG. There's our SCG. That's our MCG, right? Master cell group and secondary cell group. A master cell group is just a group of cells that's managed by the master node. Secondary cell group is a group of cells that's managed by the secondary node, okay? And so here, with option 3, we introduce the master cell group bearer, so our user plane information. Let me change colors. Let's call it green. So our user data can take this path, right? Or it can take, we can introduce also something called the MCG split bearer, okay? The MCG split bearer, we split it here. It has 2 possible paths, okay? That user plane information can come to the 5G G node B, go back over X2 user plane, and then go up S1U back to the EPC, or it can come across on the master cell group bearer. That's our option 3. Option 3A, we don't use the split bearer concept there. We just have an MCG bearer and SCG bearer. We implement an S1U connection between the 5G G node B and the EPC, and data can go this way or it can go this way. Okay, so option 3 and 3A. Then I want to get to option 3X, which many of you may have heard. Option 3X looks to be strongly the desired option for existing LTE operators to launch initial launches of 5G. Okay, so I want to point that out. Option 3X looks to be the, at this point, not saying it's necessarily every operator in every country, but in the launches that we're seeing so far, option 3X is very heavily favored. And what we see here, a little bit of a difference here, is we're going to implement something called the split SCG bearer. We showed option 3 earlier. We had the split MCG bearer. What we're doing here instead is we're running the S1U connection from the Evolve packet core, the P gateway, or excuse me, the S gateway, right, to the G node B. The G node B understands 4G interfaces and protocols. It can speak S1U. And so what we're going to do is that the user plane data, we're going to split the user plane data at the G node B, all right? And we can go ahead and send that data this away, or we can split it here and bring it this away. All right, so the big thing is that we introduce here is we have this concept of split bearer, right? And definitions here, SCG bearer, MCG and SCG bearer, those are user plane bearers. So MCG, master cell group, secondary cell group. MCG or SCG just means the group of cells, one or more cells that's managed by either the master node or secondary node. Again, just repeating some terminology there can be a little confusing. All right. And then we have the SCG split bearer. Can use both MCG and SCG radio resources with a split at the secondary node up here. That's option 3X, and that looks to be very, very popular today. Okay. Now let's move on to option 7 and 7A. And I don't know if you remember when I was showing that page with all 6 options, I said that all the ones at the top were standalone options. All the ones at the bottom were non-standalone options, right? And if you go back and remember the whole point of option 3X here, we're using the 4G packet core, right? This is an option to get to market faster by not having to deploy a 5G core. You got a ubiquitous. The implication is you have a ubiquitous coverage layer with 4G, so ideally 4G everywhere. Using the evolved packet core, you're introducing the G node B, connecting that to the E node B at the site, right? Using the X2 interface and giving it power, right? And you're ready to go, right? So that's the idea with option 3X again. With the other 2 options, option 7 and option 4, what was different for that was that we're deploying the 5G core. The first thing, major thing that stands out, right? This is not option 3 where we're sticking with the EPC. We're going to go ahead and deploy the 5G core, which means we're going to use the new interfaces. In option 3, we made the G node B understand and be able to talk LTE protocols, right, and interfaces. Now, E node B has to be upgraded. It has to understand 5G protocols and be able to talk and to understand 5G interfaces. Okay, so this is that upgraded ENB, E node B. So for option 7, all right, 5G core deployed. We've got the E node B, just like we had before. We have the G node B, just like we had before. The E node B is going to be the master node again in option 7. So you see in here in option 7, option 7A, E node B is the master node in both cases. Okay. And then just the main things here. This is kind of similar to option 3 and 3A. We have the MCG bearer, the master cell group bearer here. Remember, that's the user plane bearer. If we want to send data, we can send data, right, from the user plane function across the MCG bearer, right? Or we can go ahead and split it and take it this way, okay? MCG split bearer. And then in option 7A, we don't have the split bearer concept. What we did is we go ahead and implement, you notice we don't have an N3 here, right? Doesn't exist. If we're going to run data to the UE from the 5G core, it has to go across that MCG split bearer, right? Here, we're going to implement N3 to the G node B, and we'll have N3 here. And then we can send data this way across the master cell group bearer, or this way across the secondary cell group bearer. Those are user plane bearers, right? Across the air interface. That's our option 7 and 7A. Option 7X, again, kind of similar to option 3X, we're going to implement a split SCG bearer. So here we have the SCG bearer. We also have the split SCG bearer. Very similar to option 3X. Instead of using a 4G core, we're using a 5G core. And we're going to split at the secondary node, which is the G node B. So the data can come this way and be split like this, or it can go directly across the SCG bearer. Okay. So option 7X, and in this case, this is for an operator who's decided to go right for the 5G core. Okay. Now let's move to option 4. And in option 4, remember at that bottom of those 6 options that I showed, option 4 was that third of those 3 non-standalone options at the bottom. Again, we're deploying the 5G core for all the option 4 options. All right. And then again, what we're doing is we're basically, again, similar to like we showed before, we have the capability of a split bearer or non-split bearers. Okay. So here, and the other big difference here is who's the master node. In option 4, the 5G G node B is the master node. That's a big difference. That's the master node. So to me, the implication of somebody deploying something like this, whatever the master node is, and I want to point that out, when you decided to make the E node B or the G node B the master node, the implication is that that is your most ubiquitous radio coverage layer. Okay. So for example, for option 3X, the E node B is the master node. The implication there is that you're an operator. By far, you've got more 4G. You've been deploying 4G for years. You've got a ubiquitous layer of 4G, and so it makes sense to make that the master node, right? Because in reality, you're deploying 5G and it's islands of coverage, right? It could be millimeter wave coverage. It could be sub 6 gigahertz, whatever. But we always know that when we start deploying a new radio access technology, that it's islands of coverage to begin with, right? So when you look at these options, look closely at who's been decided to be the master node. So this one, the G node B is the master node. So to me, the implication is that you have a more ubiquitous coverage, okay, of 5G, which is kind of interesting. The implication is that you're deploying 5G first, and then you're coming back and you want to deploy 4G underneath that. I call it an underlay. You can call it underlay or an overlay. So in this case, we have our E node B. It's the secondary node. What that means, again, of course, is that all control plane, all signaling from the 5G UE that goes back to the 5G core has to go through the master node. So the dotted line stuff has to go to the G node B, whether over the air, either this way or this way. If it goes this way and go directly. If it goes this way, it has to come back to the G node B and then this way. That's for the control plane. Okay. And then this is again similar to what we just talked about earlier with the user plane stuff. We're implementing an N3 interface, right? User plane interface to the G node B. And then what happens is we can deliver the data over the MCG bearer, or we can split it. We can split it here and go that way using MCG or MCG split bearer. Okay. Over here, option 4A is the option without the split bearer, without the MCG split bearer. So we implement the SCG bearer, secondary cell group bearer over the air bearer, master cell group bearer, and then we implement N3 here, N3 here, and we can deliver data this way, or we can deliver data that way. Okay. So that's our option 4 and 4A. Oops. And then our option 5, this is also standalone. And we are deploying, in this case, a 5G core and a 4G RAN. So this is an interesting option here. Let's say that you've already got LTE. You've got an evolved packet core, and you've decided to just go ahead and move in your next step to upgrading the core first, not the RAN. Okay, so this is an option you could do. In option 5 here, in this case, remember I said that we upgrade the E node B to something called a next generation E node B, which means it talks 5G interfaces and protocols and understands them. Okay, so that's another possible option to go to, 5G core with 4G RAN. Okay. So now I'd like to go ahead and talk about some possible paths to go down for getting to where you want to go eventually, which to me is To me, the end game, one day in the future, everybody will be on option 2. That's my opinion, right? Does it make sense to go to 5G over 4G? Yes, absolutely. We get a lot of benefits from going to the 5G air interface above and beyond just millimeter wave stuff. You may have heard a lot about millimeter wave and massive MIMO and beamforming and all those kind of things, but we also get a lot of flexibility options with 5G over 4G that allow us to better service things like massive machine type communications and ultra reliable low latency communications. There's every reason in the world to go to a 5G RAN versus a 4G RAN. Okay, so this to me is the end game, and the question really is how soon do you get there, and how long does it take you to get there, and what your cost is, right? So let's just look at a couple of possibilities here. Let's start with option 1 here. Let's say that you're at option 1. You've got a 4G complete end-to-end 4G network today, and we're going to move to option 3, 3A, or 3X. And remember that I said that option 3X looks to be very overwhelmingly the choice of many operators today. And so what we've done here is we've now gone to our ENDC, E-Ultra New Radio Dual Connectivity. And I just want to point something out. If you haven't realized this yet, I had a realization. It took me a little while to get it with dual connectivity. When you think about how we deployed LTE over UMTS, what we deployed was a full end-to-end LTE network, right? The evolved packet core, the radio access network, and if you're a UMTS operator on top of UMTS, right? And then what we cared mostly about was interworking and hand down or session continuity. But if you had your islands back then, we've been doing LTE for 8 or 9 years, right? So when you drove off the 4G coverage, you wanted to either be able to, move to UMTS or CDMA, possibly. Depends what kind of operator you were back then in 3G. So either hand down, right, or do switch to the new radio access technology, but maintain your session. All right, that was the approach, how we handled the coexistence of 4G and 3G. This is different. This is very different. In this scenario, when we have ENDC, E-Ultra New Radio, 4G and 5G, right? LTE and 5G in our dual connectivity, you've got a device. It needs to be able to talk 4G and 5G, right? Let's say 4G and 5G device. And what's happening is that we're simultaneously, think of it as simultaneously communicating both air interfaces at the same time. And we saw in the options where, depending on where you did an MCG bearer, an SCG bearer, a split bearer, right? So you would have your various paths for control plane and user plane. But bottom line, I think of it just a simple picture is that I've got a device that's talking to both radio access networks at the same time. That's very different. That's what dual connectivity is. Okay. By doing that, it allows us to get to market quicker. We don't have to use the 5G packet core, right? We don't have to deploy that right away. We want to deploy that. That's the end game, right? So here, first path, let's say to option 3X. And then you could, so what we've got here is now we've deployed the 5G RAN on top of the 4G RAN, and we're still using the EPC. Let's say that we want to go to a next step, and we're just saying, okay, this is a possible next step. Now let's deploy the 5G core. We already had the 4G and 5G RANs. Now let's deploy the 5G core. So you could move from, say, an option 3X to, say, an option 7X, right? Again, watch what the master is, okay? And then we could say, well, let's move to this. Let's go from option 7X to option 4A. And what we've done is we've flip-flopped the master designation. Now we've made the G node B the master. Again, the way I think of it is that whatever you're going to make the master node, whether it's the 4G or the 5G node, I think of that as being where I've got the most coverage, the most reliable coverage. All right. So kind of the implication here is that if I'm moving from here to here, I have now over time migrated more and more traffic, more and more users to 5G. I've taken some of my older 4G carriers and I've reformed them to 5G carriers, and I'm getting more and more 5G layers of coverage. At some point, you're like, oh, I actually have more 5G coverage than 4G coverage now. maybe I want to go ahead and move to option 4A. Okay, these are some thought processes I want to take you through on how you want to do these deployments. Okay, another possible option here would be going for our migration path would be going from, say, option 3X, and just going bang right to option 2. Right, I have my 4G ubiquitous coverage. I'm deploying 5G RAN. I got the EPC. Boom, I'm going to deploy the 5G core. Right, get that out there. I'm going to move everything to the 5G. That's a possibility. Okay. Another possibility would be, say, moving from option 1, where you're all LTE, going to option 5. Right. I've got my 4G RAN. Now I'm just going to build out my 5G core. I'm going to migrate this thing to the next generation eNode B. Right. And I'm going to get all the benefits I get with the 5G core, which includes end-to-end 5G QoS, which is better than end-to-end 4G QoS. And they get the benefits of virtualization and all those things. So go from option 1 to option 5. And then over time, go to option 2. In my mind is the end game, one way or another. Okay. Let's talk about some advantages and disadvantages of these options, and I've already kind of talked about some of that stuff. Option 1, we already know that that's a already existing 4G network, so we've got the evolved packet core. Radio access technology is LTE. This is standalone. All right, an already deployed network. So standing by itself, you can't provide 5G services, right? Option 3, evolved packet core, non-standalone, right? Master radio access technology is LTE, that's ubiquitous coverage layer. We're going to aggregate the throughput over LTE and the 5G new radio interface. Of course, at any given time, if I have 5G deployed, I'd like to deliver the data as much as possible over the 5G RAN because it is the most efficient air interface. But guess what? I can deliver it over 5G and 4G at the same time with this option. Leverage the existing LTE coverage ubiquitous layer that's everywhere. Use 5G for capacity. All right. And the disadvantages, 5G new radio coverage may be islands of coverage to begin with, right? It takes time to actually deploy all this, right? Another possible limiter is availability of 5G spectrum, right? We know that all the pre-existing spectrum that we've been using for 4G all along is a candidate to become 5G spectrum, right? When we refarm that spectrum, there's also new spectrum that's out there, for example, millimeter wave and some of the new sub-6 gigahertz spectrum coming out. Okay. Option 2, that is end-to-end 5G, right? So the 5G core network, 5G new radio for the radio access technology, standalone, full support for 5G. But what's the potential disadvantage? The investment cost to deploy full end-to-end 5G core and 5G RAN at the same time. Okay. Option 4, 5G core network, non-standalone, master RAT. Master node will be the G node B, right? Full support for 5G related services. And again, investment cost to deploy full 5G core and full 5G RAN, right? And we've also got to upgrade the eNode Bs to be able to talk and speak 5G interfaces, right? They can talk to the 5G core. Option 5, all right? 5G core network, enhanced LTE, standalone. Remember, this was the one where you have the 5G core with the 4G RAN, okay? So you can get full support for the 5G related services using the enhanced LTE RAN. Remember, we call it the next generation eNode B, right? Disadvantages, does require full deployment of 5G core and the upgrade of the eNode B. Support 5G. services. And then option 7, also non-standalone, right? 5G core, and also next generation eNode B, all right? Advantages, we can aggregate the throughput over LTE and 5G NR. That is one of the advantages of having both rats deployed at the same time, right? Leverage the existing ubiquitous LTE coverage layer. 5G is used for capacity. And of course, just like option 3X up here, we may have islands of coverage to begin with, and then we're going to grow them as fast as we can. We have the spectrum. And then here, above and beyond option 3s, we deploy the 5G core instead of just staying with the 4G core. Okay, those are just wanted to go through some of the pluses and minuses, or pros and cons, if you will, of these deployment options. So we already talked about some of these considerations that will influence the path you take as an operator, right? In your country, what are the regulations, right? What's your regulatory bodies doing about spectrum, in particular, freeing up spectrum for 5G? Okay. UE availability is always a huge one. How can you get your supplies of your UEs? And this is a big deal. Like, if, for example, if you were going all the way to an end-to-end 5G network right away with no 4G, you might be talking to your suppliers and say, I just need 5G mobiles. Although if you're going to allow for roaming, you probably need to talk 4G as well, right? But talking to your vendors, getting the availability of those UEs, and also making sure that those UEs have full support for that option, or those options that you want to deploy. Okay, so UE availability to me is always the biggest thing, actually, in terms of limiting your true time to market in terms of selling services. You got to have those UEs that you can sell, right? In our coverage and capacity also is really big. For example, a lot of people hear about millimeter wave, and millimeter wave is a wonderful thing. Here in the US, there's a lot of millimeter wave spectrum, so it allows you to deploy very big channel bandwidths. And because you can deploy big channel bandwidths, you can get really big speeds. But millimeter wave, we know, is so high in frequency that it's got some severe limitations on coverage, right? And so, what's the deployment situation for millimeter wave, right? Does it have to be on small cells? Does it have to be in hotspots? Things like that. Also, if you're going sub 6 gigahertz, right? Are you able to deploy in some new spectrum that's perhaps not at the traditional 6, 7, 800 megahertz range, but might be in the 2 gigahertz to 3 gigahertz range, right? Understanding what your coverage capabilities are, and also what is your service type. This is a big deal. Is it going to be mobility, full mobility, or will it be fixed wireless? We've been hearing a lot today about operators who are very interested in fixed wireless for enterprises. So this is a big deal. We know that there's a lot of operators out there who offer fixed access services, for example, Ethernet to enterprise customers. 5G is really being looked at seriously is it possible to deploy that same kind of service, high speed Ethernet-like speeds to buildings, but doing 5G, right? Interworking is also a big consideration. So if you have a pre-existing 4G network, right now, if we're doing this dual connectivity, that's an approach. That's what's called tight interworking, actually, tight interworking. But bottom line is, do we need to one day be able to do handovers, from 5G down to 4G versus dual connectivity? Okay. And then what are your services? Really important, right? We know that high-speed internet has always been the key service for a long time for consumers. We know that we have new things coming out. We hear about things like massive machine type communications, ultra reliable URLLC, low latency, ultra reliable low latency communications. autonomous car, things like that. What's your service set? Okay. So in summary, our, our architecture, we've got the 5G UE, the new device, and we know dual connectivity is going to be a device that talks 4G and 5G at the same time. We've got the 5G RAN, the 5G core. We can deploy the 5G network as either a non-standalone or standalone type of option, right? And then we've got to think about where are we going? Are we an already existing LTE operator? And we want to get to one day being all 5G, right? It does make sense to migrate all your 4G to 5G one day, right, over time. What options do you go through on the way there? Also, if you're not an existing operator, but you want to become an existing operator, as in with your own physical network, let's remember every time we launch a new technology, regulatory bodies and governments across the world want to usually foster competition, right? So there's an possibility here for an MVNO to become a physical operator, okay? And folks, that's it. Just real quick, I want to show a curriculum, then we're going to go to Q&A. Just want to let you know that in our 5G curriculum, we've got a full foundational set of courses, and then we've got intermediate level, we've got advanced level. Again, this presentation will be made available to you, and also the recording of this. And so with that, now I'd like to go ahead and move to Q&A. All right, give me a second here. Okay, first question, good question. Does the NFV framework fit in for all of the deployment options? And what I would say, let me back up here. Give me a second here. Let's look at the options. The way I look at it is that NFV particularly emerges when you have the options that have the 5G core. Okay, so option 2, option 5, the option 7s, the option 4s have a complete capability of deploying that net NFV based evolved packet core. All right, and then also if we're deploying on the RAN side along with the 5G core, obviously with the G Node B is completely NFV, right? Fully compatible with the NFV vision, all right? But also if we will deploy the eNode B where that eNode B has been upgraded to be able to speak and understand 5G interfaces and protocols, also allows for NFV, okay? So it depends on the option. Look for that. Are we deploying a 5G core? And then are we going ahead and deploying that option where the eNode B, for example, here needs to speak the N interfaces and protocols, okay? First good question. Very, very good. Another question. Is the virtual RAN part of 3GPP deployment options DUC split functionality? All right, let me back up. It's a little bit of a longer question. The question is virtual RAN part of the 3GPP deployment options? And what we're talking about is the newer functional split. For those of you who are not familiar with it, the baseband unit that we've known about and we've been using for a long time in 3G and 4G is being further decomposed into what's called the centralized unit and distributed unit, all right? And with that decomposition offers the possibility for virtualization in the RAN, okay? So the question is vRAN part of 3GPP deployment options DUC split functionality? Are the 5G deployment options impacted by NFV and vRAN? For example, data center location, distance, latency. The answer is yes to that question. And again, it's in the new decomposition of the baseband unit. What we can do is that with that decomposition, think of the baseband unit as having DU and CU, and now we're going to split that. All we're going to do is we're going to take the higher layers of the protocol stack in the BBU, and that's going to be in the that's going to be in the centralized unit. The lower layers, as in like physical layer, MAC layer, right, are going to be in the distributed unit. What you can do is you can split those, and depending on how you do it, if you move the DU all the way out to the pole, out to the cell site, it probably doesn't make much sense to virtualize that. All right. However, the way I look at it is that if for the CU, the centralized unit, that is something that you can move to a more, quote, centralized part of the network, as in like a data center. Your point, a data center, MITSO, right? Some operators use the term mobile telecommunication switching office, even potentially could be a CRAN hub site, could be. Anyway, if you deploy, let's say you deploy it at a data center or a MITSO, it makes sense to me to go ahead and virtualize the CU and now have VRAN where CU is virtualized. But the reality is, you technologically you can do it any way you want to do it. It's just what makes sense, right? So to me, if you keep DU and CU together, you can virtualize all that. If you split them apart, it makes sense to virtualize CU. That's my answer. Okay. Very good questions. And we'll have time for one more question. Somebody asked me to repeat what MCG and SCG bearers are. So let me do this. Let me go back to a picture. Back to 4A. And this can be a little bit confusing when you first get into studying the 5G technology and standards, because there is a lot of new terminology. So master cell group, MCG bearer, stands for master cell group bearer, right? MCG. It is an over-the-air user plane bearer. Okay, over the air interface user plane bearer. So the MCG bearer is associated with the master node, right? So remember, the master node is the node where any signaling from the UE to get to the core must pass through the master node. And this is, let me change my colors because I don't want to confuse you. Let me see if I can get a kind of a brown. All right. So control plane. Okay, in the brown there, has to get there. If it's possible, right, that we can have signaling radio bearers for control plane, right, RRC connections, kind of stuff. You notice here, that's the signaling anchor, right? It's the master node. The control plane stuff has to go through here one way or another. And here we actually implement something called XN. Okay. So if you have a master node, right, any of the over-the-air interface like data radio bearers, those are master cell group bearers. Okay, user plane. Then we have the secondary cell group. SCG, same thing, over the air user plane bearers, right? And this is associated with the secondary node, all right? So in this dual connectivity options, ENDC options, either the 4G node or the 5G node is designated the master, and then the other one is designated the secondary, right? And by definition, MCG bearers are associated with master nodes, SCG bearers with secondary nodes. Over the air user plane bearer carries user data. Okay. So hopefully that answers that question. One last thing in terms of terminology, master node is correct. Master node in this case is also called master enode B. So don't be confused if you heard the term master enode B. Master node and master enode B are completely correct terms. Down here, this could be, I'm sorry, this is gnode B. Whoop. Master gnode B. Sorry about that. Almost made that mistake. Down here, enode B. This would be a secondary enode B. Okay. Secondary node, secondary enode B. Master node, master gnode B. Okay. And with that, I think I've answered all the questions. Folks, we're at the end of our session. Thank you for joining our session. Really enjoyed delivering this all to you, and thank you for the great questions, and hope to see you in the future in another webinar or another class. Thank you, everyone.